All right, Physics A. I recorded this video as a kind of goodbye. I can't pretend this is anything I've ever done before or even really know what to say. But I did want to acknowledge how much I enjoyed having you this year in class, how important you were to me, and I hope that you keep in touch. I love to hear from former students, and I know you're going to do great things going forward. You've had some unique experiences, but you know, some good comes out of unique experiences. Isaac Newton spent 1665 and 1666 inventing modern science and calculus and everything like that. So some of the things you have learned, some of the thoughts you've had, some of the mindsets you've developed right now, they will serve you going forward. And just in this time, be gentle with yourself and be gentle with everyone around you. I wanted to mention what I hope you got out of physics. This class is really the yardstick of the universe. It really wants people to ask, why do things happen that way, and how do I measure things? And more importantly, it was a class that built a lot of models. This is a problem I don't expect you guys love very much, two-dimensional forces. But it gave you a routine, it gave you a set of practices that if you did those steps, you could start figuring out all the various things that might affect an object's motion. Obviously, a primary goal of the class was to teach you how to do some physics. But it's really this idea of organized approach to problem solving, using models. That's really the reason this class is considered so important for lots of branches of science and lots of careers that you may have, not just physics. So we started with relatively simple problems. We taught you how to organize the information you were given. We taught you how to pick equations, pick models to use, and then solve things in a step-by-step manner. We spent most of first semester and into second semester just taking that same theme and gradually adding more and more complications to it. So pretty soon you could do it with not just one force, but multiple forces. Then you could do it not just in one direction or dimension, but in two dimensions. You could do things not just moving straight, but circular. And they're all variations on the same theme. And that's really how you should kind of view the world if you're trying to do it in a quantitative manner. Start with a simple model and gradually expand it, adding in new ideas, new suggestions, until it actually works, until your model is sufficient to explain what you're trying to study. We added in the effects of time into this model. We saw that we could introduce ideas of momentum and impulse. We added in the idea of energy, and we gave you a problem-solving approach for that, where you considered all the energy before an event happened and all the energy after an event happened, and you could relate an object both before and after that way. We finished up looking at circuits and trying to come up with some rules for how charges move through circuits. The point is, in all of this, we just wanted you to have a strategy so that going forward, whatever field you're in, you have an organized way of approaching problems. If you got that out of this class, then I'm happy. I made this for you guys, and it's called a concept map. And I don't expect you to be able to see it in the video right now. But it's kind of my opinion of how everything we did this year ties together. So I'll include a link for this so you can take a look at it. And it might be interesting to try to make your own. How do you think what you learned this year relates to each other? How would you make decisions over what concepts you're going to use? And you don't even have to just include physics on this. You could sort of think about how do the ideas you've learned across your time in science, across your time in school, how do they apply? Some of the problem-solving skills that you develop in history classes, doing things like documents-based questions, they really help in making logic decisions. So you should think about those too. But one goal I hope you always have as you move forward is when you learn something, try to figure out how it fits in with everything else you do. How does this new knowledge add to me as a person? How can I apply it? Concept maps are a tool to help you do that, but other tools are good too. Just make sure you're asking those questions. Go out into the world, be awesome. Tell us how awesome you are. Keep in touch. Good luck. It's been great having you.